man, he got you good.
Yeah. Glad to see you still have your twisted sense of humor. Stop. That's something that make you feel better. Keep it in mind. I've been after years, 6, 7 weeks, nothing. Oh, penis in there, strictly street level amounts. Man, it's crazy.
How's that?
You're right. The only one that's coming. Creatures.
Hello.
Let's start it.
Okay. So I'm just kind of wondering where your logic is with some of this stuff.
My logic is right.
How?
It's just right. But we'll get into. Are you there?
Right here. I'm right here. So looking at 215.3, feeders shall be protected against overcurrent protection in accordance with Part 1 of Article 240. Yep.
Mm-hmm.
You have to protect the conductors. Where a feeder supplies continuous loads or any combination of continuous and non-continuous loads, the rating of the overcurrent device shall not be less than the non-continuous plus 125% of the continuous. How can you ignore that?
Well, you need to go over and learn how to apply Article 240 and look at 240.4 B and C. If you go look at 240.4 B, you're 800 amps or less. It tells you to go up to the next standard size. And to give you an example, say I calculated a load that say it came up to 58 amps, and you go over and look at table 240.6A, you're going to pick up a 60 amp. But if I go over and look at table 310.16, pick up 75 degrees C column, you got a 65 amp for your conductor. So in parentheses there, you can protect the conductor or the load. So you could go up to a 60 amp or 70 amp. When you get over to 240.4C, and it's talking about overcurrent devices rated over 800 amps, you calculate the load, and then you size the conductors based on what that load is. And once the conductors are sized for that load, it tells you the device it's over 800 amps will not it'll be the conductors will be the of equal value or exceed the rating of the overcurrent device, so you drop down. That's how you do it.
Where in 240 does it talk about sizing a breaker or an overcurrent device per the load?
You got to be freaking kidding me. What do you think Article 240 is? It deals with overcurrent protection device. It's literally the title of the article.
Yep, but where does it say that in Article 240 that I need a 80 amp breaker for this, for so much continuous load? Where does it say I need a 30 amp breaker for so much load? Where does it say I need a 100 amp breaker for so much load?
Okay,
it doesn't. 240.4.
Let's look at this. Where you're looking at breaker. Where do you go size the conductors at? See, you want to pick and choose where you look at. You want to do feeders.
I'm not picking and choosing anything.
Yeah, you are. Go look at 215.2A1. You go over and pick up the continuous and non-continuous load for sizing the feeder. You do it on 125% for the continuous, 100% for the non-continuous. It doesn't matter. Hold on, let me finish. It doesn't matter if I do branch circuits, I do feeders, I do services. I'll give you all the sections. Go look at 210.19A1, 210.20A, 215.2A1, 215.3, and then go look at 230.42A1. They're all exactly the same when you go into sizing this. And once you do that, you do all your sizing for the conductors. You got to go over and you look at sizing your overcurrent device. All the same rules are in place for sizing at 125% or 100%. Then you go over to Article 240 and your rules are there for your overcurrent protection device.
All right. So your 724 amps of continuous load got us to 905?
Yeah.
I think it was. So why can't I use a 850 amp overcurrent device? Why can't I use a 825 or 863? What says I have to use a 900?
A 900 amp is the next one below it.
But where does it say you go to the next one below?
It's not a standard size that's listed in 240 table 246A, but you can go on any website, Google, whatever, and they have 900 amp available. That's where you're dropping down to the next size.
I'm not debating that they don't have that available, but 240.4C just says that the conductor has to have an ampacity that is equal or greater than the overcurrent device. If I put it on an 850, is that conductor, if I do parallel 4-aughts, is that still greater than the 850? Yes, it is. So why couldn't I use an 850? Why couldn't I use an 825? Why can't I, you know,
you go
why couldn't I
down to
use
the
any of that?
next standard size.
Where does it say you
This
go
is
down to the next
exactly why
standard
you have
size?
problems understanding about
No.
doing a
Where
minimum,
does
max
it
size,
say?
and maximum size for your overcurrent device for a motor. And then you guys over there, y'all completely disregard the fact that if I go look at an AC unit and it has a hacker breaker rating, they had minimum and maximum on there. You're basically telling the rest of the industry we're all a bunch of freaking idiots because we don't agree with y'all.
Where does this say that I go down to the next standard size or anything in 240.4C? All it says is
It can't
that.
wow. This
No,
is
where does it say
amazing.
it? Show me where it says in
What?
240.4C that I have to drop down to that standard size.
Okay, listen.
Or whatever.
Let me. It says where the overcurrent device is rated over 800 amps. Pay attention. The ampacity of the conductors it protects shall be equal to or greater than what?
The rating of the overcurrent device.
That's right. So that means you got to go down. You can't go up.
Okay, fine. You go down, but why can't I go down to an 850? Why can't I go down to an 835? Why can't I go down to an 825?
If you're going to say that, just take it down to a 20 amp overcurrent device.
Agreed.
You know how
that's
stupid
the thing.
you sound?
No, I'm not sounding stupid.
Yeah, they're
the
telling
code
you
as
here
it is
you
written.
cannot exceed the overcurrent device can't exceed the conductors. It literally says it.
I agree. But the thing is, there's no minimum size that I need to install when it comes to 240.4C.
Who said anything about a minimum? I said you drop down.
But the thing is, you drop down to where?
To
Where does it say you drop down to
whatever
the next? Where does it say that in the code? Where does it say in the code you drop down?
You calculate a load of 905 amps. You go over to table 310.16. You pick up your 75-degree C column, come down, pick up 4 off. They're good for 230 amps. We paralleled it 4 times. That's 920 amps. Okay, my conductor size is set for the calculated load, right?
Yep.
You agree with that? Okay. So I've already set the conductors for it. Now it's telling you the conductors have to be equal to or greater than the overcurrent device. So what am I going to do? Go up on the size overcurrent device?
No, you're going to go down with the overcurrent.
Thank you.
But where does it say
900 amp?
But where does it say you have to go to 900? Why can't I go to 850? Why can't I go to 825? Why can't I go down to 800? Why can't I go down to 500?
The way they set it up is you drop down to whatever the size is below the next size that's below.
Where does it say that in the code?
Right there, it says it.
No, it does not.
Yeah, it does.
It says the ampacity of the conductors that protect shall be equal or greater than the
what
rating
size
of
are
the
you going to
overcurrent
put
device.
it at? What size you going to put it at? A 20 amp? 50 amp, 60 amp.
There's nothing that says I can't, because what is 240.4?
Oh, so you're saying this section's wrong? You're saying this section?
No, I'm not saying the section is wrong. I'm saying 240.4 is protection of conductors. If I put 900 amp wire on a 100 amp breaker, am I protecting those conductors? Yes, I am. All right. Would you agree with that? Am I protecting the conductors?
I've already read to you when you go look at 240.4B. Okay. I've told you, you go up to the next standard size overcurrent device. You can protect the ampacity of the conductors. You get an option there. I just gave you a good example of that. Do you need another?
I asked you a flat out question. If I put a 100 amp breaker on 900 amp wire, is the wire protected? Yes or no?
Hell no, it isn't.
It's not? How is it not? Oh, so if I put a 100 amp breaker that's going to trip at 100 amps.
You just said 900 amps.
Wire, I said the wire is 900 amps. The breaker's 100 amps. Am I protecting the wire?
Now, see, that's what I'm talking about right there. How are you even going to fit that wire on the breaker? See,
why can't you just answer a simple yes or no question?
No, that's a
why
stupid
can't you answer a simple yes or no question?
You try to twist and turn something because you're wrong.
I'm not twisting and turning anything.
You're giving something that's completely freaking stupid. What are you going to do? Cut the conductors in and fit it underneath the breaker terminal?
No, I'm just showing you how your logic is totally flawed.
No, it ain't flawed.
Yes, it is.
Okay, tell me what size you're going to go to then.
Okay, when you size a feeder, branch circuit, whatever, 3 things you have to do. Does the breaker or the overcurrent device conform, well, let's just say a feeder, 215.3? Does the conductor.
Oh, don't leave
No,
out
hold on. Just, I
215.2A1
let you
either.
talk. Can you let me fucking talk? Jesus Christ. 215.3. Does the breaker or fuse good with that? 215.2. Is the wire good with that? And then the last part of it is the wire protected by the overcurrent device according to 240.4. If you say yes to all of those things, you have a good install. So you can't just ignore the language in 215.3 that says the overcurrent device shall be at least 125% of the continuous load plus the knot. Why do you think that's in there?
You know what's amazing about this is
What?
if I calculate anything at 800 amps, I go up to the next standard size. Automatically, it's already set in place and everything. Exactly what you're talking about. But you
Why
just
can't
no.
answer?
I am answering.
Okay, sorry.
But when I go look at 240.4C, it tells you do your calculation, everything, the size and capacity of your conductors. And then once that's decided, then it tells you the conductors have to be equal to or greater than the rating of the overcurrent device. But it doesn't say that when I get over and look at 240.4B. And that's what I'm saying. You're trying to take one section and you're using that one section and just disregarding what it says right here. And you want to say, well, hell, if that's the case, I can drop down to a 100 amp overcurrent device. It doesn't say that.
There's nothing that says I can't. All it says in 240.4C, what does 240.4C? It says the capacity of the conductor has to be equal or greater than the overcurrent device.
Let me ask you this. When that's calculating everything, are you going to tell everybody that's watching this podcast that when I do the calculation and I calculate everything, just say I do everything at continuous duty, are you going to tell me that everything is going to be operating at continuous duty the whole time?
I have no idea. And
no, it's not. I've never seen that once in my life. And that's why they allow you to drop down, because there's a diversity that's built into that. But then again, it's guys like you that come out here and try to take the code and twist it to meet these wild accusations and stuff of how you want the code to read. And y'all have done this over and over until I came onto the groups and everything. Y'all were getting away with it. Well, now you're not getting away with it because I'm showing people that you guys don't know what the hell you're talking about.
Even David said you were wrong. Engelhart, you said
that's his opinion. That's his opinion. I disagree. You got your own union instructor that is embarrassed by the things that you say on here and the way you talk to people. Oh yeah. And I've already posted on there so you can see it, and I can show you the rest of the conversation. And they're actually looking at using our publications because they are correct.
I'm not going to use your publications.
Oh, anyways, see, there's already certain unions that are using them. We also have IAC different places that are using them. It's not through the international. Because international, show you how good your union brothers are over there. You used to have it through NJTC, and then they broke off and then created Electrical Training Alliance. And then Electrical Training Alliance tried to sell their material to IAC, the non-union. I know that 100% fact. But that goes to show you just how good the union brothers are out there.
Don't care.
Yeah, that's what I'm saying. It's good for us. What's good for us, y'all just do what we tell you. I've been through all of this, and this stuff you're getting into here and the way you're trying to teach us, you're teaching it wrong. And I'll tell you this one other thing. NFPA used to publish our publications. They had their engineering staff and everybody look at it, edit it, and they agreed 100% with the way that we calculated this. And that's a fact.
Show me that. Show me that documentation of them agreeing with you that you can ignore 215.3.
It goes to show you you don't know inner workings about anything that takes place in the electrical industry. NFPA paid. You be quiet for a minute. NFPA paid for the right to publish our publications. And when they did that, one of the things that was in the contract is they went through and edited everything, and we made sure that there were no mistakes in those publications. And that's something we did it for 2 cycles. And they edited our code change books, our design books, our journeyman books, our master's books, 70E, everything. And there were changes that they caught and stuff they wanted added in, which we did. And that's a fact. Now,
And
for you to
I
come in,
don't
you're
give a
basically
shit.
saying that the engineering staff at NFPA are a bunch of idiots too, because they actually agreed with this calculation. And
Show
furthermore,
me that.
they've been
Show
using
me
this
that.
they've been
Show me
using this
that.
calculation for over
Show me
30
it.
years, being used in
Show me
all
it.
different apprenticeships and everything.
Show me it.
And nobody has ever questioned this calculation.
Show me it.
Yeah, I keep all this documentation just so I can show it to Jeremy and
Sucks.
and go
Well,
through all of this. And I'm telling you, do you actually think we've been writing books for over 30 years and nobody uses them?
I didn't say that.
They use our publications all over, and nobody's ever questioned this calculation. NFPA never questioned it.
Really? Nobody's
Yeah.
ever said 215.3, you have to actually read the whole thing.
They did read the whole thing, and it
It
tells
says,
you.
okay, so what does
Yeah.
it say? Where a feeder supplies continuous loads or any combination of continuous and non-continuous loads, the rating of the overcurrent device shall not be less than the non-continuous plus 125% of the continuous load. If we have that 724 amps at a continuous load, that is 905 amps. It says the overcurrent device cannot be smaller than that. It literally says that in 215.3, does it not?
See what I like
Does
about
it say
this?
no?
You
Just
just
answer
leave the
fucking yes
first.
or no.
You just leave the first sentence out.
I'm not leaving the first sentence out. You have
It
you have
says
to
go
protect the
look. It
conductors.
says protected against overcurrent in accordance with Part 1 of Article 240. I think is what it says.
But 240 doesn't tell you how to size a breaker. It tells you how to protect a conductor. They're two different things.
Okay, this is why I want everybody to watch this podcast.
Two different things.
If I size my branch circuits, I size my feeders, and I size my overcurrent protection devices. Don't care which one you do.
Okay.
If it's non-continuous, you take it at 100%. Continuous, you take it at 125%. End of story. Doesn't matter which one it is. Then it tells me to go look at Article 240. Now, if I go look at Article 240 and I look at 240.4b, what does it say? It says go up to the next standard size or protect the conductor. Exactly what you're talking about. I don't disagree. But when I get to C, it says those conductors have to be equal to or greater than that overcurrent device. That means I go down.
Totally agree. I totally agree they have to be that. But the thing is, the overcurrent device has to be at least 905 amps. It says it in 215.3.
No, it doesn't.
It does too.
You've calculated the conductors are calculated the same way that the overcurrent protection device is.
No
you don't
shit.
change the calculation at all. You have to come over here to 240.4C for the sizing. And it's
what does it say in 215.3? What does it say? Why can't you just read what it says in 215.3?
I just agreed with you. Did you not listen? I said if I calculate the conductors and overcurrent device, I do them exactly the same way.
Okay.
Then when I get ready to size the overcurrent device, it tells me if I take it at 125% for continuous loads and my device is 800 amps or less, I protect the load or I can protect the conductor. It gives you the option. Then when I go to C, it says the conductors have to be equal to or greater than the rating of the overcurrent device. In the discussion, you size the conductors first, and the overcurrent device is sized based on what those conductors were.
The overcurrent device is based on the calculation of 125% of the continuous load plus the non-continuous load. It literally says that.
And it tells
I know,
you
but so where does it? So it has to be at least 905 amps. The overcurrent device has to be at least 905 amps. Does it not?
Where does it say that my conductors have to go up to 1,000 amps?
Because you have to have an overcurrent device at least.
It doesn't say that.
Amps.
It doesn't say that.
Stop.
It says once you calculate the load and you size those conductors have to be equal to or greater than the rating of the overcurrent device. Once those conductors have been sized. See, this is what I'm talking about. You're picking and choosing where you want to apply that.
Anything.
Yes, you are.
How?
I just told you. I do branch circuits, feeder services all the same way. Once I size those conductors, then that overcurrent device is based on them conductors. I'll prove it. Okay, if I look at 240.4B, say I calculate a load at 58 amps, I can protect the load, which is 60 amps, or I can protect what? The conductor at 70 amps. I get a choice there. Okay, that's why it's in parentheses, because I size the conductors, and once the conductors are sized, then I can decide how I'm going to size that overcurrent protection device. Same thing comes down here to 240.4C. I size the conductors. Once I know what the ampacity is, then my overcurrent device has to be equal to the conductors have to be equal to or greater than the rating of the overcurrent device. It says
So
it.
So the second sentence in 215.3 means nothing.
Listen to me one
Yes
more
or no?
time.
No. What is it?
When I
Just read
size
it. What
my
does it say?
conductors and overcurrent device, they're sized exactly the same.
They are calculated the same. Yes, they
That's
are.
right.
So you need a 905 amp wire and a 905 amp overcurrent device. It literally says in 215.3 that the overcurrent device shall not be smaller
There's
than
no
the
such thing
non-continuous.
as a 905 amp overcurrent device.
No shit, there isn't. So you have to go up to 1,000.
No, you don't. You go down
Yes, you
because
do.
you've already sized your conductors.
Then you have to have bigger conductors. That's how it works. You don't just drop your overcurrent device to an arbitrary number that you're pulling out of your ass, is what you're doing.
No, I'm
You're
not.
saying you have, yes, you are. You're saying you have 920 amp wire, so you drop down to a 900. Again, why can't I drop down to an 800? Why can't I drop down to a 700? Where does it say you drop down to a number that ends in a zero?
It says it right there.
No, it does not.
The conductors it protects shall be equal to or greater than the rating of the overcurrent device. So I go down.
I agree. But where does it say you have to drop down to a 900? Why can't I drop down to an 875 or an 850?
Well, just drop it down to a 50 amp. Drop it down to a 100 amp. That's
again.
That's the kind of language that somebody uses when they're wrong. Oh, what if I wanted to do this?
Wrong.
What if I wanted to do this? I mean,
how am I wrong?
Y'all play the what if game constantly. I can't tell you how many times y'all come in and when you're losing, you bring up some other question. What if this happened? What if this happened?
Because
it's sort of like the GFCI debate. Oh, what if this happens? What if this happens? Even though they didn't have any technical merit or deaths that were happening, but we need to put that GFCI in there. It's the exact same thing you're doing.
Hey.
Y'all come from the same cut. You don't really. You pick and choose where you want to play something and give these what ifs because you don't really study the code and know how they've calculated all these years. This exact calculation, where do you think we got it from?
Don't know, don't care. I honestly just
an example calculation comes from the American Standards Handbook. And so that's been out there forever, and they were calculating it exactly the same way. You saying all them people before you were a bunch of idiots too?
Show me proof that they calculated it the way you did.
I'll go find it, and I'll put it up there and show you exactly. I'll take a picture of it. I've already had to do this many times with y'all and show you where it come, and then y'all just go off to something else because you were proven wrong.
Show me where they do a calculation. They have a continuous load and a non-continuous load. Over 800
I'll show you where they do it, where they calculate everything fully at continuous.
Okay, whatever.
And then they drop down. You know why they're able to drop down one? Because they realize that not every load is going to be operating at full continuous load on that service. It's not going to happen. And you got a diversity in there. And see, that's part of the problem. You guys don't understand diversity, apparently.
I'm asking you, why does it say that in 215.3 then?
It says the exact same language when you're looking at sizing the conductor too.
I know, but so why would they even put that in the overcurrent device? Why would
because
they put
you
that
size it, you size the wire size and the conductor the same. And once you size the conductor exactly the same, when you get ready to look at sizing the overcurrent device, where does it tell you to go? Article 240 part one. And when you go over and look at devices 800 amps or less, you can protect the load or the conductor. And then once you're over 800 amps and the conductors have been sized, it says the conductors have to be equal to or greater than the rating of the overcurrent device.
Where does
It doesn't
say,
say, it
where does
doesn't,
say
it doesn't
anything?
say kick the conductors up to 1,000 amps or above that and then drop down. It says you've already sized the conductors here.
Where does it say already size the conductors in 240.4b? Where does it say you're protecting a load in 240.4b? All it says is the next higher standard overcurrent device above the amp. What is 240.4? What is
Okay,
the
let me explain it to you. You
No,
go
what is
over the next.
240.4?
I've always said this. You take it at 125%. It says the next higher standard size overcurrent device rating can be used. Okay, so I calculate a load at 50 amps. What's the next size above that? 60 amp. Then if I go over and look at table 310.16, I pick up my conductor, which is a number 6, is good for 65 amps. Then looky there, see the parentheses there? Above the ampacity of the conductors being protected. I can protect the load. That's based on what I calculated, or I can protect it based on the conductor. So I could put a 60 or 70 amp on there. And we have also, guess what? We've also had that in our publication for over 30 years, and NFPA agreed with that too.
What is 240.4?
It's for protection of conductors, and that's what I'm trying to tell you. You've already sized your conductors. Okay, and once you size your conductors, 240.4C says the conductors it protects shall be equal to or greater than what? The rating of the overcurrent device.
Okay, you said 240.4b gives you two options. You can protect the load or protect the conductor. I don't see anything talking about protecting a load in 240.4b. That just says
then explain to me why did they have to put in parentheses above the ampacity of the conductors being protected?
Because they're saying you can protect the conductor above its ampacity. They're just saying that if I have a 65 amp conductor, a number 6, I can protect it with a 70 amp breaker. That's all it's saying.
Okay, if it's 58 amp, what size overcurrent device can I put on there?
If the wire's 58 amps?
Yeah.
If the wire's 58 amps, you can protect it with a 60.
No, the wire, there's no such thing. See, this is what I'm talking about. I hope everybody's paying attention to this. He goes, oh, if the wire's 58 amps. The next size above that 58 amps is what? A number 6, 60. Which is good for 65 amps. Okay.
You said overcurrent.
So you telling me I can't protect that load with a 60 amp breaker?
You can protect the wire with a 60 amp breaker. But again, where
no,
does it say
no. I didn't say the wire. I said the load. I calculated a load at 58 amps. Can I protect it with a 60 amp breaker? Yes or no?
Sure.
Okay.
I mean,
now if I go up to a 65 amp number wire. 6 conductor and it's good for 65 amps, can I put a 70 amp on there?
Sure can.
Okay. Now you learned how to apply 240.4b correctly.
I've been doing that my whole career is doing.
You just argued with it just now that I had to go up to a 70 amp.
What?
You just said it. And then you said, well, if I have a 58 amp,
you go to a 60 amp breaker. If you have a 50, if you adjust and correct your conductor down to 58 amps, you can protect it at 60 amps.
And that's why I'm telling you, they got the next higher standard overcurrent device rating, and then in parentheses it says above the ampacity of the conductors being protected. You got two options there.
So what two options?
There's two options. I can protect the conductor or the load.
You can protect the conductor or you can protect the load.
That's right.
But where does it say anything about protecting a load in 240.4? It says it all talks about is conductor
says the
protection.
next standard overcurrent device rating. The next size above that 60 amp. Or it says above the ampacity of the conductors being protected, which is 70.
Where does it say or? It says the next higher current device rating above the ampacity of the conductor.
Why do you think it's in parentheses?
Because it's saying that you can protect the conductor above its ampacity. That's all it's saying. Is that what you're saying? It says something else? Where's the other words there?
I'm telling you, you can protect the load or you can protect the conductor. Either way will work.
Either way it will work.
That's
Protecting
exactly
the load.
right. And that's the way they've been doing it.
How do I
freaking 30, 40 years people have been
How
doing it that way. Do you actually teach this in your apprenticeship?
So if I have a bunch of loads that add up to 58 amps, how is that 60 amp overcurrent device going to protect those loads?
Because that's your calculated load.
That's your calculated load, but the thing is, how is that one breaker going to protect something I plug in downstream?
Now, see, now you're changing something that's different.
No,
What is it? What are you feeding? Because see, this could be anything.
It's a load.
That's an open-ended question there.
It's a load. You said that if you have 58
so you're
amps
going to
of
tell
load,
me you're going to take and have 58 amps that's going out feeding on this branch circuit, and then you got all this stuff plugging into it.
say
Is that
branch
what you're
circuit,
telling me?
but whatever.
Oh God! See, this is what I wanted. That's why I wanted to do this podcast, so everybody could see where you do these stupid what ifs, and nobody would ever see this out in the field. Have you ever worked out in the field?
I'm asking you to read the code and show me the words that you claim that are in there. Again,
this is
where does
amazing.
it say anything about protecting a load in 240.4b?
It literally, when you size your conductors and overcurrent devices, you do them exactly the same. And 240.4b tells you the rules and how to size the overcurrent protection device once those loads are calculated.
It tells you how to protect the conductor. It doesn't tell you how to calculate a load or calculate
show
the size
me
of the
anywhere in there where it's telling you that the size of them conductors have to be increased so I can get up to a size overcurrent device that meets your so-called 1,000 amps. Where does it say that on the conductors?
It says that your conductors have to serve 125% of the continuous load plus the non, which is in that case was 905 amps.
That's right.
The overcurrent device also has to be 905 amps. It literally says that the overcurrent device has to be 905 amps.
And where does it say the conductors need to be increased in that size to meet that overcurrent device?
Well, you could get a 905 amp breaker and to be fine. You could get a 920 amp breaker and be fine.
No. See, that's the what if game right there.
Because
when you come over and you look at 240.4c, it says that the conductors have already been sized here by 215.2A1. Once it's sized, then it says the conductors have to be equal to or greater than the rating of the overcurrent device. You did the exact same calculation for both of them. Then you come over here and it tells you to go to Article 240, Part 1, and this is where your rules are.
Where does it say anything about calculating anything in 240.4c?
Oh my God. I just told you, you can go look at 210.19A1, 210.3, 215.2A1, 215.3, and 230.42A1. Same damn rules for sizing the conductors and overcurrent device. You do your calculation. That's where your 125% is for continuous and 100% for non-continuous. Once you calculate that, 215.3 tells you to go where? Article 240.41, come over here and here's your rules.
But it also says the OCPD has to serve 125% of the continuous load plus the non-continuous, which is 905 amps in our case.
And this is why listen to me. This is why you're allowed to go down to that 900 amp, because they realize that 125% is not going to be operating the whole time for everything on that service. So you got diversity in there. And oh wow, how could we take and drop 5 amps and believe that breaker would hold? I mean, listen to what you're saying. That is the most ridiculous thing. And that's why they allow you to do it, because they know it's only a few amps here and there. It might get up to 10, maybe 15, but you'll be able to drop down. That's why you do these calculations and you do parallel runs and things like that. And you try to get it just right above where it is, so you don't have to drop down that far. So you know the overcurrent device is going to protect it, because you don't have that service operating at full load like that the whole time. You got diversity there.
Okay, so take that 700 and what was it? 24 amps of continuous load. Add 600 amps of non-continuous load to that. What would you get?
700, you had 724, and you were
Continuous.
Let me 724 times 125%. You got 905 amps plus 600.
Yep.
1505.
Okay, so if I parallel 350s, which is 310 a piece, which gets you to 500 or 1550 amps, you're saying I can drop my overcurrent device all the way down to a 1200.
Well, let me
Because
look.
that's the next standard size below that.
Just give me a few seconds. Let me go and look, because you're asking something right off the fly here, and I've got to look and check everything to see what we got here. Just give me a minute. Okay, let's go here. All right, let's see what we got here. Okay, I'm at 1505. So let's see. Let me look at this. Okay.
You need 350 is good for 310 times 5.
1550. Okay. I'm adding up. Just give me a minute. Let's see. I could do. Let's go here. Okay. Good with that. Not good with that. Dun, 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 dun. Okay. 1089. That was close. Let's see. Got 310. At 1550. Okay. And then you had 905 plus 600. 1505. Okay. I just want to make sure I got all that right. 1505 and then 310 times 1505. So 5. That'd be 45 amps. 45 amps would be difference. And I'd say you drop down to a 1500 amp, and
what says you can't drop down to a 1300 or 1200 or?
Well, I just add up. I'm telling you what I added up. You've got you've got here. You took a 350. You took that 310 amps times 5. That gives you 1550. If I take my calculated load, which was 1500 amps, you got 45 amps that are there, and that 45 amps, I'll guarantee you'd probably be a lot less than that, but I'll guarantee you got diversity in there that nothing is operating at 1500 amps total through that whole service at a full load the whole time.
So where does it say I can drop down to? Why can't I drop down to 1200? That's next standard size.
240.
That's next standard size is 1200. Why can't I drop down to that?
That's a standard size, but you can purchase a 1500 amp. All you got to do is go online and look. They do this all the time. I've been out in facilities all the time where they've put like a 900 amp. They put a different non-standard sizes that they've used throughout the facility for calculated loads just like this. I can't tell you how many places I've been, and you'll see calculations exactly the way I'm showing you right here.
So what's preventing me from putting a 1400 amp overcurrent device on that?
Because you go down, it says the conductors have to
Okay,
be
I'm going
rated
down.
to or greater than, and you
I
just
am
go
going
down to the
down.
next one. See,
Where
this
does
is
it
the
say go
what
down to the
this
next
this
one?
is the what if game. Well, what if
No,
I
it's
did
not a
this?
what
What if
if
I
game.
did
It's
that?
what
Yeah.
the code is saying. It's what the code says. The code says I just have to protect the conductor per its ampacity.
Okay, well, let's
If I
do
have
this.
a
If you're going to do that, well, let's just kick it up and let's say that I go up to 1,000 amps. Well, the overcurrent device can't exceed the thing. Well, so I'm not going to put 1,000 on. I'm going to drop down and put a 700 on it. Oh, well, there's nothing in the code now telling me I can't do that.
there is nothing the code tells you can't do that. So
See,
you could.
that's how ridiculous that sounds right there.
I
See,
know it's ridiculous. I'm just
what I'm
saying
saying, you're picking and choosing right there. You're
I'm not
telling me,
picking
oh
and
no, I
choosing
have to
anything.
kick the conductors up to 1,000 and then drop down to 1,000 amp overcurrent device. Well, if that's the case, why don't I just drop the overcurrent device down to 600 amps?
Because the overcurrent device has to serve 125% of the continuous load plus a non-continuous load. It says that right
It
in
is
215.3.
serving it. It is serving
No,
it.
it's not.
Yes, it is.
125. No, stop. 125% of the continuous load plus the non is 905 amps. How is 900 equal or greater to that 905? It's not. The overcurrent device has to be at least 905 amps.
Oh, well, that's interesting. So you're telling me that that service right there is going to be pulling 905 amps at all time?
Never said that. I'm just saying
Okay,
what the code says.
that's what I'm trying to tell you
I'm
right
saying
there.
what the
That's
code
why
tells you to do.
no, that's not what it's telling you to do. It's
It
telling
is
you
literally
that
telling
once
me to
you're
do
over
that.
800 amps, it tells you that the conductors, you've
God.
already sized them. They have to be equal to or greater than the rating of the overcurrent device.
There's nothing in 240.4 that says anything about calculating an overcurrent device based off of a load. It just talks about protecting a freaking conductor. You calculate the size of the overcurrent device itself in 215.3. And 215.3 says the overcurrent device shall serve 125% of the continuous load plus the non. Does it not say that?
Where does it say that the conductors have to go up to 1,000 amps?
It doesn't. It just
There
says
you
that.
go. See, that's picking and choosing. I'm
Where
trying
does it
to
say?
tell
I'm
you,
not
you've
picking and
already
choosing
sized the
anything.
conductors. You've already sized the conductors, and you size your overcurrent device the same way. I agree with you if it's 240.4B, but once I go look at 240.4C, it tells me I have to go down that the conductors have to be equal to or greater than the overcurrent device rating.
And your overcurrent device has to be 905 amps per 215.3. It literally says that.
If that's the case, then why did it even take and refer you to Article 240.4, Part 1, if you wasn't going to apply what it says here?
Because you still have to protect the feeder.
See, that's where you're getting confused. There's a reason that's the very first sentence, and then the sizing comes after it because they want you to come over here to make sure you know how to size the overcurrent device properly.
But you're not sizing an
It's the
overcurrent
first
device
sentence
there. You're
into
protecting a conductor.
it's
You're
literally the
protecting a
first sentence
conductor.
in 215.3. It literally is the first sentence.
So if the first sentence in all these code articles is gospel and everything else we can just fucking ignore.
No, you still have
that's
to
what you're
size
saying.
everything based on continuous and non-continuous. But I have to go to Part 1, Article 240 to see how to size the overcurrent device, and if there are any rules in there that supersede what's here.
Supersede what? There's no superseding anything. They all work together. 215.3 says the overcurrent device has to serve 125% of the continuous load plus the non. That is 905 amps for 724 amps of continuous load. That's literally what it said. Okay. So
when you
the
go
overcurrent
look
device
at,
cannot be smaller than that.
Listen, where feeder supplies continuous load combination, blah, 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 you take 125% for continuous, 100% for non-continuous, okay? I go look at my conductors and I look at 215.2A1. It literally says where you have those loads, you size it exactly the same. No disagreement. Then I go over and I look at Article 240 because when I size overcurrent device, the first sentence says, hey, go look at Article 240.4 part 1 and I go look at 240.4B, exactly
just
what
says
you're saying is correct. I size based on whatever that calculated load is or the conductors. Then I come down here, then it tells me what to do on the overcurrent device once the conductors have been sized, and it says those conductors have to be equal to or greater than the rating of the overcurrent device. It literally takes you right back over there.
It says feeder shall be protecting its overcurrent in accordance with part 1 of Article 240. It doesn't say you go to 240.4C or B or whatever. It just
says you
says
go to
you
part 1, and what is that in? It's in part 1.
Correct. I would agree with that, but it doesn't specifically tell you that's how you size your overcurrent device. This sentence, where the feeder supplies continuous loads or any combination of continuous and non-continuous loads, the rating of the overcurrent device shall not be less than the non-continuous plus 125% of the continuous. It literally says the overcurrent protect device cannot be smaller than that. It literally says that right there.
Well, see what it says. 240.4 conductors other than flexible cords,
Oh my God.
flexible cables, and fixture wires. No, I'm looking at 240.4, what it says, protection of conductors. Shall be protected against overcurrent in accordance with the ampacity specified in 310.14 unless otherwise permitted or required and where. Oh, looky there, 240.4 A through H. So my conductors were sized, and then my overcurrent device is based on what it tells me to do there for the protection of those conductors, and it tells me to go down.
So why does it say where a feeder supplies continuous loads or any combination of continuous and non-continuous loads, the rating of the overcurrent device shall not be less than? That means it has to be at least 125% of the continuous plus the non. It literally says that in 215.3.
Nobody's disagreeing with that. I'm saying that's exactly what it says. And you do the conductors exactly the same size. And when I come over here and look at 240.4, it literally says in the heading to look at unless otherwise permitted or required in A through H. I come down, I size it exactly the way you're saying in 240.4B. But when I get to see the conductors are already sized, and it's telling me that the rating of the conductors have to be equal to or greater than the rating of the overcurrent device. It literally tells you to go and look underneath here and do it that way.
But the overcurrent device has to be at least 905 amps per 215.3. Does it not say that? Does it say that in 215.3 that the overcurrent device has to be at least 125%?
But it tells you to go look at Article 240.41, and when I get it looking at the protection of the conductors, this is how it tells me to do it. You sized your conductors, and then these are the rules for the overcurrent device. It literally says it. I'm not making it up. Anybody read this?
Making it up.
Everybody following on watching this podcast, just look. It comes in and it tells you to do it.
Okay, it tells you that your conductors have to have an ampacity equal or greater than the overcurrent device. Where
in there does it tell me the conductors have to go up to 1,000 amps? Where does it say?
Well,
that?
if you have a 905, if you can pick out a 920 amp breaker and put it on there, you're good. Are you not?
It says that has to be equal to or greater than the conductor.
Well, if the ampacity of the conductors is 920, is 920 not equal to 920?
There's no such thing as a 920 amp overcurrent device. And that's why they tell you, that's exactly why they tell you this, because they know you're not going to come equal out every time. Exactly the same reason that they take in 240.4B, and you have an option to size the overcurrent device based on the load or the conductors, because they realize it doesn't match up to a size breaker you can use. It's the same thing.
Where does it say anything about figuring a load in 240.4?
Okay, pay attention one more time. When I size the conductors, I'm protection of the conductors here, okay? When I'm looking at protection of conductors, it says when once I've sized my conductors, it tells you in 240.4, unless otherwise permitted or required and where, 240.4 A through H. Then you come down and pick your rules up for sizing the overcurrent device. I either go up, if I'm 800 amps or less, I can protect the load or the conductors. When I come down and look at the... It literally says the next higher standard overcurrent device rating. I can go up, or it says, or above the ampacity of the conductors being protected here. That's why it's in parentheses.
You literally said that it says you can protect the load or the conductor. Where's the word
Are
load
you
in
actually teaching this
240.4b?
to apprentices?
Where does it say load in 240.4b?
One more time. It doesn't matter if you're doing branch circuits, feeders, or services.
God.
You got
Why
the
can't you just
exact
answer the
same
question?
rules.
Why can't you just
Because
answer the
it
question?
refers you back over here. You
I'm not
quoted
denying it
215.3.
refers you there.
215.3, it refers you back here. You have taken and sized your conductors. And once you get into the protection of the conductors, once you sized them for whatever the load is, it tells you to follow 240.4A through H.
So you're
It
telling
literally
me
says
that
it. I don't know how you can argue when it's telling you to do it.
So you're telling me that in the next code cycle they can totally delete that second sentence in 215.3?
No.
Why
The
not?
conductors and overcurrent device are sized exactly the same when you're doing continuous and non-continuous loads. Once you've calculated what the load is, then you come over, you size your conductors, and then for the protection of those conductors, sizing that overcurrent device, it tells you in 215.3 to go look at Article 240, Part 1, and then you pick up 240.4 for the protection of those conductors, and it tells you to what is otherwise permitted or required in 240.4A through H. And then when I pick it up, those conductors have already been sized, and they say them conductors have to be equal to or greater than the rating of that overcurrent device.
Okay, so you just said that you size the conductors per 215.2A1, 125% of the continuous load plus the non. You get that wire size, right?
Mm-hmm.
Okay, so then again, if all you're going to go to is 240 or Article 240 and go to 240.4 to size the overcurrent device, why do they have that second sentence in 215.3?
Because you size the overcurrent device in the conductors the same.
No, you just said you
disagreeing.
size the
Okay, let me
overcurrent
ask you
device
this.
based on the conductor.
Since you like to pick and choose, then why don't we allow it if it's 800 amps or less to drop down?
Do what?
I'm trying to make a point here. If I have a device that's 800 amps or less, I have to go up to the
Hold on a sec.
to protect whatever's calculated.
So what now? I'm sorry, my phone rang and it cut out.
Okay.
What did you say?
If I have to take and I have a device 800 amps or less, why do I have to protect the load or the conductors? I'm not allowed to go down.
Yeah, you are.
No, you're not. You can't go down below that calculated load.
No, hold on a second here. So you're saying that if I have a 100 amp wire, I cannot protect it at anything less than 100 amps?
Yeah, say I calculate it. I've got a 98 amp load. Can I put a 90 amp overcurrent device on that?
No, but
thank you
again,
so
there's
much.
nothing in
That's what I'm trying to tell you.
There's nothing in 240.4 that talks about a load.
See, that's what I'm trying to tell you, because when I go look at 240.4B, if it's 800 amps or less, I have to protect that calculated load or the conductor. So if I calculate and I have a conductor that goes up above that, I can protect that conductor or the load. They give me the option there. But when I come down to 240.4C, I can't do that. But
where does it say anything about protecting a load in 240.4?
It's protecting the load because you sized your conductors. And if you look at 240.4, that's a protection of your conductors when you size your overcurrent device, and it tells you to look at 240.4A through H.
240.4 doesn't give a shit how you got your conductor.
Oh, well,
all it's saying is
I don't even know why they put overcurrent protection in there then.
240.4 has nothing to do with protecting a load. It's protecting of conductors. If I have a 4-aught conductor, which is good for 230,
wait
and I have no idea
what... now stating if I had a 58 amp load, I couldn't put a 60 amp overcurrent device on that?
I didn't say that. You can put a 60 amp overcurrent device.
Then if the conductor was 65 amps, which is number 6, could I take and put a 70 amp on there?
You sure can.
There you go.
I'm not debating any of that stuff. All I'm saying is that 240.4 doesn't give a shit what your
Sure
load
it
is.
does.
It's just
Sure
saying
it does. Because you
No, it does not.
calculated the
It
load
does
and you
not.
sized your conductors, and that overcurrent device, they're telling you for the protection of that conductor, I could take and put it and protect that load that was 58 amps, or I could have done it at the conductor, which was 65 amps, and put a 70 amp on it. That's what 240.4B. It doesn't allow me to go down. But once I calculate the conductor size for over 800 amp overcurrent devices, then it tells me the conductors have to be equal to or greater than the rating of the overcurrent device.
Where does it say anything about protecting a load or serving the load in 240.4? Nowhere.
Oh my God.
Nowhere. It just says, okay, 240.4B just says I can protect a conductor above its ampacity. If I have a 4-aught, which is good for 230, I can protect that at 250. That is the only thing that 240.4B is telling you. That is the only thing it's telling you. What else is it telling you there? Where does it say, oh, well, you have the load and this and that? No, it's just saying that if you have this conductor, you can protect it up to this. That's it. That's all 240.4.
That's what I'm trying to tell you.
It's not telling you how to.
When you look at it and you do the calculation and you size that conductor over in 215.2A1 for a feeder or branch circuit 210.19A1 or service 230.42A1, I calculate everything at 125% for continuous, 100% for non-continuous. Doesn't matter if I'm sizing the conductor or the overcurrent device. Okay. That's done.
Yes,
that's right.
Thank you.
It tells you in 215.3, it says go look at Article 240, Part 1, and then I come over look at the protection of conductors. It tells me to follow the rules that are permitted or required in 240.4A through H. And then you pick that up and it tells you how to size your overcurrent device based on the loads that you've already calculated.
No, where does it say anything about
the name of the chapter is literally overcurrent protection.
True, but where does it tell you how to size the overcurrent device based off a load in 240?
How do you think you got a load in order to determine how you're going to size your overcurrent device? That's the stupidest thing I've ever heard you say, and that's saying something.
My God, 215.3 tells you literally how to size the overcurrent device. It says the overcurrent device shall not be less than 125% of the continuous load plus the non-continuous. Does it not say that? It says that. Now, it has to be at least that big. It literally has to be that big.
It literally says to go look at Article 240 Part 1 too.
True. But where does it say in Article 240 I can ignore 215.3?
Oh my God. You size the conductors and overcurrent device exactly the same. Once you've got the conductor size already done, then it tells you what to do for the protection of conductors in Article 240 that literally deals with overcurrent protection device. And it says, unless otherwise permitted or required in 240.4A through H. It literally says it.
Yes.
And then you come over, it tells you when you're doing 800 amps or less, you go up. Once you get over 800 amp overcurrent devices, the conductors have to be equal to or greater than the rating of the overcurrent device. So I'm going to go down. That's it.
Okay. But it's only talking about protection of a conductor.
So
it's not talking about load calculations.
So in other words, what you're saying is 240.4 doesn't apply to any of this because I'm going to do the calculation here and I base everything off 215.3. That's what you're saying.
Didn't say that it didn't apply. I'm just saying that the overcurrent device has to be at least 905 amps.
And there you go. And what I'm trying to tell you is you got your load calculated, then you size your conductors. Once those conductors are sized, then you look at 240.4 and then you've got your protection of conductors. And this is what it tells you to do.
So then you're violating the second sentence in 215.3.
No, you're not violating it. And
yes,
the reason,
you are, because it literally says that.
Let me explain.
You
know why you're not violating it? Because they realize that once you're over 800 amps, all those loads are not going to be operating at the same time, and there's a diversity in there. Therefore, they allow you to go down knowing that your breaker is going to be large enough. They just want to make sure that the conductors are large enough for the load that you calculated.
I would love for you to show me the substantiation for that, saying that that's the reason that you go down.
Well, I'll tell you, you're the first one I've ever heard that has said this isn't right. And this has been in our publications for 30 years. NFPA agreed, all of them that have looked at it, went through our calculations and everything, and they all agreed with exactly what we were saying.
Dude, I showed that video last week when I hopped on and was going over this thing originally, and I sent the link to all the instructors in my school, and they're like, "Holy shit, dude, what is this guy talking about?"
Well,
Dude,
that
you
explains a
have
lot, because it shows exactly, like one time we were there, they were using our publications and they were trying to tell us something was wrong, and then they come over, and once I explained it to them, then they got pissed off and walked off because they didn't
proof,
know what they were doing.
proof,
And this is part of the problem.
proof.
We get a lot of new instructors coming in. There's big turnovers and everything, and these guys haven't been schooled properly on the NEC, and they get people like you coming in telling them stuff like this, and then they believe it when they hadn't actually studied out of a publication that actually teaches them the right way to do it.
Okay, so I have showed you over the past handful of years code making panels saying you're wrong.
Oh, that's good that you bring that up.
Wrong.
You brought up and said we were wrong about this, and I said no, we're not. You said the code making panel said, and what ended up happening? It got the Standards Council, and they were chopped down and slapped on the hands and everything else.
Okay,
and I actually, and I'm gonna give you an example of one right here. I submitted a public input that dealt with the concrete encased electrode. I sent all the information in, the previous code making panels, how they voted on it and looked at it. And that code making panel didn't even have the decency to give me a substantiation of anything that I posted on there. They just said, no, you can do this. And I still stand by that today, that's the way that they had been doing that for all that time. And I showed the information there and showed how the previous code making panel voted on it, and they just ignored it. So when you start getting in talking about these code making panel members, and I'll say another thing about some of these code making panel members, it's just like Thomas Dmitrovich. He was on the other day and he said, well, if we don't put it, we manufacture these devices, if we don't put it in the code, they won't use it. That goes back again to exactly what I was saying when we looked at 210.8F. There's no freaking outlet there at that equipment. That's just nothing but a termination. But they come in later after that, and they started putting GFCIs on that. Now what's going to happen? They're going to have a fight on their hands because a lot of these manufacturers are not going to put up with it, just like the electrical vehicle people did. And they slapped code making panel 12 on the hand also, because they told them they had the first revision and second revision, and they didn't prove that GFCI needed to be there. And we got a video there, Tommy talking about he had to go over and talk to them, explain what they were trying to do, and he probably whined and dined them, who knows what he was doing. But they put all that information in there and did all this work, added 625.54B, and you guys came on and said, see, the code making panel said y'all wrong. Oh, looky here. Even at the General Assembly, they voted that this should go in, and y'all are a bunch of freaking idiots. And then it gets to the Standards Council. Well, guess what happened? It got turned down.
Okay, now show me the documentation from any Standards Council that says the main reason that this stuff got kicked out or this is not applicable is because there is no outlet like you and Bill claim.
Well, I don't have to show documentation, because I give you good examples and showing you exactly what the code says. And you know what amazes me?
But I'm asking
what amazes me more than
you
anything, if I go look at Article 314, the very first sentence, when you go, or the heading, it says outlet. And then when you go down, and just to give more examples and see it, argue this one, if I go down and I look at, say, 314.27, okay? If you go look at 314.27, what does it say over? It deals with outlet boxes. Okay. It literally calls it an outlet box. And then it gets in, and even this is what amazes me more than anything. That say I deal with a ceiling fan, for instance, it says outlet boxes or it says an outlet box system. They're telling you the box is the outlet. It's not just some random point you want to pull out and decide, something that is sets out there in infinity, and we just pick and choose where we want to decide that outlet is. It doesn't work that
So
way.
314.28 talks about pull and junction boxes. Does that mean the box itself is a pull and a junction?
See, you just pulled everything I wanted to say. Where in there does it say anything about an outlet?
In
314.28. Where does it say outlet in there?
It says pull and junction
boxes. That's right.
It's
a pull or a junction
you said
box.
The
it's
box.
Not an outlet. And that's what I'm saying.
You just said the box is the outlet.
Exactly. I didn't say every box is an outlet. You can have all kinds of different boxes, but where you're connecting, say you put a device in there, or you're connecting something over to that where you've got utilization equipment. I have utilization equipment. Well, if I put a receptacle in that box, the box is the receptacle outlet. It literally says over in the definition where the outlet, the receptacle is where you install it inside the outlet box, the receptacle box or the receptacle outlet. It installs inside there. It's not some point.
Okay, where does it say? Where does it say box?
Where does
in?
Go ahead.
No, where does it say box in the definition of receptacle outlet?
Okay. Let's.
You said the box is the outlet, so
let's go over and look at receptacle outlet. Let's just go. You want to go there? We'll go there. I have no freaking problem with it. This is just one of those, once again, that y'all pick and choose where you want to take and apply something.
Not picking and choosing anything.
Yeah, you
I'm
are.
just asking you. How am I picking and choosing?
It says an outlet where one or more receptacles are installed.
Okay, where does it say box?
Now, where's the outlet?
The outlet is a point where current is taken to supply utilization equipment.
Oh, well, if that's the case, that should be the receptacle, shouldn't it?
Yep. Okay, but if I have an AC disconnect with a built-in receptacle, is that not a receptacle outlet?
You got your question. So I'm gonna take you back over here, and we're gonna look at 314.27 again. I'm gonna show you how ridiculous this sounds, what y'all are trying to say. All right.
Okay.
Now, if I take and I look at a box and I have a ceiling outlet, it says at every outlet used exclusively for lighting, the box shall be designed and installed so that a luminaire lamp powder can be attached. Boxes shall be required to support a luminaire weighing blah, 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 and shall be supported independently. Okay, this is the words, shall be supported independently of what? The outlet box. Unless the outlet box is listed for not less than the weight to be supported. Oh, wait a minute. I thought it was just a point. How do I put weight on a point? That's beside the point. Then it says the interior of the box shall be marked by the manufacturer to indicate the maximum weight of the box shall be permitted to support. Now, if I look at that, let's just say I have a box that's up in the ceiling there, and I come off of that box with some flex, and I go over to a luminaire. Where's the outlet now?
What was it again?
If I have a box in the ceiling, I come off of that box, and I go over with a piece of flex, and I hit a lighting fixture. Where's the outlet?
At the lighting fixture.
Oh, that's amazing. So depending on where I want to put it and everything, I can just pick and choose if I want the outlet at the luminaire or at the box.
Well, where's the point current is taken to supply the utilization equipment? It's at the luminaire. So let me ask you this then. You have a switch, Okay, you have a switch. You run MC cable from a 1900 box to a light to another light you just daisy chain like half a dozen lights on one switch. Where's the outlet there?
Well, if it's coming straight from the switch, it'd be at the switch location.
Okay, then what are the conductors from the switch? What are the conductors after the switch called?
Well, what if it was a three-way? What is it going to be then?
I'm
See, that's what I'm
asking
saying.
you-
You're picking and
asking you
choosing
what
where
those
you
con-
want to
I'm
apply
not picking
that,
and choosing anything.
because you
I'm
have
not
to
picking
have
and choosing
you have
anything.
to have an outlet somewhere, and you're picking and choosing where you want to put that outlet. And see,
I'm
let me
not.
ask you this: then why did the code making panel make a statement? And just give me one example, just one. Just give me one example where they stated that the disconnecting means could be an outlet, but most of the time it's not. Just one installation where there could be an outlet for a disconnecting means. They made that statement. I can pull that up for you too. I'll get that on there. But tell me where, just one location where that would happen.
Well, if you have a piece of equipment that has a manufactured whip on it and you go right to a disconnect, well, then the disconnect's going to be the outlet.
Oh,
Right?
what type of equipment would that be?
Fuck, I don't know. I'm just saying.
Yeah, see, that's one of them. What is? I've never seen anything like that, but I have seen the exact installation you just gave me, and I just told you that is an example right there of where you have a switch. That's a disconnecting means. That is, you're coming off of that disconnecting means, and you're going over feeding them lighting fixtures.
Okay. So you're feeding the light fixture, but again, what are those conductors from that switch to the light fixture? Are they branch circuit conductors? Because the branch circuit ends at the outlet. Are they premises wiring? Because the premises wiring ends at the outlet.
Branch circuit is what comes over to the switch. That's your branch circuit, and then after that, you're going over feeding whatever it is you're going to feed.
Okay. What are those conductors called then?
They're just conductors going over. They're terminations. It'd be no different.
They're not branch circuit conductors?
The branch circuit conductors is what sized is. See, this is why y'all don't know what you're doing. If I take and bring, okay, let me ask you this. If I'm doing the branch circuit conductors that are sizing over there, how do I size those conductors going over? Now, don't forget, this branch circuit could be feeding other things. I go look at 210.19A1, and if they're continuous loads, whatever, non-continuous, I size it based on there. That's the branch circuit that's coming over feeding all of that. Okay? Now, that's not, when I leave at this net, that's not branch circuit conductors at that point, because I could be coming up with number 14, but I fed over everything over here, the branch circuit with number 12s.
What? Those aren't branch circuit conductors?
No, they're no longer. They're not branch. See, that's where y'all have a problem, and you don't know how to take the code as a whole and use it properly. If I size coming over, I could have a branch circuit coming over feeding multiple rooms. And one room I come over here and I run some number 14s over here for this switch for this room. Then I come out of the box for this other room. They're number 14s, but I ran a number 12 over there. That was my branch circuit.
So if I run number 12s to the light, those aren't branch circuit conductors?
If I know what the load is in that room and I don't need anything more than a 14, why the hell would I put a number 12 on there?
Just to make it easy, because a lot of trucks are going to be carrying around a lot of 14.
See that once again, that shows if you were a contractor, you wouldn't do that. You would put number 14 in there because you save money doing it that way, because it's not part of calculating for the branch circuit. The branch circuit was the number 12 conductors coming over there. Then I came off of there and then I supplied my rooms what I needed. That's not a branch circuit anymore.
So you're going to just come out of that box and just run a shit ton of number 14s.
Whatever I need to go over there to feed that room. If I need to go over there with a number 14 to that switch, and we'll do it. Yeah, I would use a number 14. You're not a contractor. You just go in and you're one of those code junkies that teach at a apprenticeship and you haven't been out in the field and seen what they do in the real world. And that's why I'm trying to tell you, that's a branch circuit coming over. Then I come off over there. Then I run some number 14s to feed that room. The branch circuit stopped at that box up there.
Okay, so what size breaker are you using for all this?
It could be a 20 amp.
So you can put 14s on a 20 amp circuit.
You're going to put four. Have you never done electrical work for you? Have you ever been into a house and seen where they come over with number 12s and then they split off there with number 14s? Have you never seen this before? Are you
That's
really?
a violation.
Are you really serious?
You can't do that. You can't do that.
Oh,
if you have a 20 amp circuit, you need number 12.
I hope everybody.
Stop.
I hope everybody is watching this pot. Matter of fact, I'm gonna make sure everybody sees this. That right there just showed that you don't know field work and what is actually done out in the field. They do this all the time. Here in Texas, that is a common freaking practice. They do that all the time.
Come off of a 20 amp circuit, go to a box, and then after that split off, you go 12s from the 20 amp breaker to a box. Then after that, you go separate ways with number 14. Is that what you're saying?
Yeah, they do that.
Oh my God. How? That's not legal.
Yes,
what is the smallest conductor you can put on a?
Yes, it is. They've been doing that for everything. They calculated load. It's no different if I have a tap and I go over tap and I tap down to something smaller. They do that in the kitchens too. And they even have a rule for that. That is a common practice. Oh my God.
You can ignore the small conductor rule then. You don't have to. It says that let's see here.
For a branch circuit, do you not know the difference between a branch circuit? You have a branch circuit that comes over there. Once you come off from there, that's not the branch circuit once you're coming down. They do this all the time with taps and everything.
Stop. So you say coming out of you have a 20 amp breaker in your panel. You have number 12 NM cable going to a box somewhere, let's say in the living room. And then out of that box, I go out with 14s, and you're saying those 14s are not part of the branch circuit.
They're part of the circuit, but it's not sized as a branch circuit over to it because they're doing it for a separate room. They do that all the time. That is common practice.
Not
you need to check with some contractors and ask them if they do it. You're going to find you're going to start. So you need to go out in the field and see what they're doing, and you'll learn how to actually what installing is.
Did houses in the field, and I have never ever. If I did that, the inspector would fricking shoot me down flat, and he should.
No.
Yes. Okay, you're saying that I could put 14s on a 20 amp circuit.
You're going over with a number 12. See, that's you're conflating what I'm saying. I'm saying you're coming over with a number 12. It's no different than where they do taps and stuff. Are you saying they can't do that?
No, I'm saying you can do taps, but what do taps have to end up in? And you have a length limit to taps and all of that stuff. All right. You can't just fricking what you have a 10-foot tap rule, 25-foot tap rule.
You know, it amazes me. I don't know how they can take and have smaller fixture wires inside the fixture there and that be okay.
Because it's part of a listed piece of equipment.
There you go. Well, that's interesting. So show me where you have a listed piece of equipment and any documentation whatsoever, and they tell you there's an outlet there. I've never seen that.
Where does it say? Okay, they don't care if you call that an outlet. An outlet's defined by the NEC.
Oh, apparently they do care, and that's exactly why you had the EVSC go out and fight against them trying to require GFCI protection. If they didn't care, they wouldn't have been up there arguing about it. In other words, they're putting inhumane rules in there trying to require this GFCI protection when they didn't even have the technical merit to do so. But I'm just
I
giving
totally
you
agree.
points.
But again,
You're coming over and you're
again,
feeding all this. A branch circuit is what comes over, and then they branch off from there.
again, the EVSE manufacturers, they were fighting against GFCI protection. They weren't saying there's no outlet there, but whatever.
Yeah,
So
that's why they were wanting to put the GFCI protection in, because they're trying to say it's an outlet, but they're about to get a kickback on that from all these manufacturers. They're going to start fighting back against this.
well, they can fight against the GFCI protection, but it doesn't change the fact that there's an
No,
outlet.
there's
but
no
whatever.
outlet there.
Literally is.
Nope.
Anyways, again, coming off of I just still trying to wrap my head around this, that you're saying that I can come out of my panel in my house off a 20 amp circuit or 20 amp breaker with number 12s to just some random box, and then out of that with number 14s, as long as I want to do whatever I want.
I'm telling you what they do in the field.
I'm asking you if that's code compliant.
Oh,
Is it code compliant? Is it code compliant?
I'm telling you what they do. I
don't care what they do. I'm telling you, I'm asking you if it's code compliant.
I'm not going to argue with you over it. I'm telling you, in the field, if you get out there, you'll see them do it all the time, and the inspectors pass it.
They shouldn't.
I'm telling you.
Again,
I'll get people on our podcast come on there and tell you, yeah, that's what we do.
Super. Again, inspectors they shouldn't allow that. That is, a branch circuit ends at the outlet. It doesn't end at a box that you just randomly put somewhere.
And that's exactly why we have our podcast to explain this. And you got people that are on the code making panels, a lot of them that just get put on there by some manufacturer, a company, or they represent some organization, and they get into stuff and they haven't been properly trained on it. My dad had to go through exactly the same thing. They had to bring him into the hazardous location. And at that time, they didn't even allow special experts, but they put him on as chairman. And I did all the paperwork for him and everything, because the code making panel that had been on there previously screwed it up so bad that they had to bring in experts and stuff to get it right. And that actually happened.
So what is wrong? So again, what code making panel screwed up not allowing you to put 14s on a 20 amp circuit?
I'm telling
who personally did that? What cycle? Whatever? I mean, you're saying these people are not trained and not vetted and not this and that, and you're saying all the. How many code making panels said that you were wrong about
the branch circuit that's going over? If they run a branch circuit over there, they've calculated the loads, and they're saying they need, say it's 20 amps, or just say it's 16 amps, and say they calculate it continuous, gives you 20 amps. So they got the branch circuit coming over, and then they'll branch off of that and feed the fixtures and everything in that room with a number 14, because it is not going to be pulling that type of load in that room. They do it all the time.
I'm not saying that there's that the house is going to burn down if you do that. I'm just saying the code does not allow you to do that.
Oh man.
I know they used to do that all the time. I've seen it happen, but again,
you just told me a while ago you'd never seen that. Now you're telling me. You're telling me you've seen it. Make your mind up.
I've never done it. I've seen it. I've never done it. But the thing is that it's, again, what? Okay, you're like, yeah. Is there some stupid shit in the code? Yeah. Is there stuff that you may not agree with? Yeah. But you can't just say, oh, I'm just going to ignore this because I think it's stupid.
When I look at the code, I go through all kinds of sections and everything and make an informed decision. And it's just like arguing about the sizing of the overcurrent protection device for over 800 amps. That's the way they've been doing it for God ever. I mean, It's been in our publications for 30 years. NFPA's looked at. We've had all these instructors worldwide look at. We sell our books worldwide. I mean, they've bought them in all kinds of other countries. Nobody has ever questioned that calculation. Hell, some of the union apprenticeships have used our books before, and we've also had IAC, and they've used them, and none of them have questioned that calculation. They agree with it. That's a fact.
I would love to see proof of all
Well,
of that.
how do you prove
But-
something when they never asked you to change it? Because they were teaching it and they never asked you to change it. If it was wrong, don't you think we would change it?
I don't know. I'm not running your business. You are.
Anytime somebody calls, if they find something, we make the change if we messed up on something. We're not perfect, but nobody has ever requested to change that, ever.
Then they are just so wrong, man. They are just wrong.
So basically, you're saying you're smarter than 30 years of instructors, engineers, all the NFPA staff that looked at it. You're basically saying all these people are wrong.
No, I'm not saying
Well,
that
sure
at
you
all.
are.
I'm
You're
saying
saying that if you're saying
I'm
they
saying for you
agree
to
with
show
that,
me,
because that's exactly how
I'm
it's been
saying
in
to show
there
me
for
proof
30
that they
years.
agree with you. I say to show me proof that they agree with you. You bring up all these claims and you have zero proof of any of this. Any of this.
If somebody called us and told us this calculation was wrong and we looked at it, we would change it. But it's never been changed. We've never been called. I asked Dad, has anybody ever called on this? He goes, no. He goes, that's correct. And we're talking to one of the most world-class known instructors in the world is Stalkup Senior. Anybody that has ever sat in his class, he'll tell you he's the best. Even instructors will tell you he's the best they've ever sat in. He had instructors come out. Hell, Mike Holt used to come to his classes. That's a fact.
Okay. Don't care. Do
No,
you think that
I'm
impresses
I'm
me?
just
I don't
trying
give
to
a
tell
fuck.
you, one of the foremost experts on the NEC, everybody said so. He says the calculation's right.
Everybody, show me proof.
God,
everybody
have you
says
seen the awards he's collected over the years? From
again,
the biggest
not what
associations
I
and
said.
organizations there are. You don't get those type of awards unless you know what you're doing. He's been on some of the biggest cases that he was special expert on. He's represented UL, he's represented OSHA as their expert. The reason they hired him because he knows what the hell he's talking about. And I'm telling you, he says here that that is exactly the way that the committee intended it. And when he was writing those publications, he was going to the committee members, making sure this is what they wanted. And this is what their intent was when he wrote those publications. And that all started back in 1971. And that's when he started doing his little publications and everything. And then when he got into the early 80s, that's when he started coming out with his big publications with American Tech, and they were sent out for review and everything. And he was going to all the code making panels, making sure this is exactly their interpretation on how to size it.
Okay, so how about this? How about have all these code making panel members on with you and Bill and just say, hey, this is how I calculate it. Is this right?
See, there you go. Once again, I'm telling you, they got people on there now that get on there and they're put on by organizations and stuff, and they probably have never done a lot of this stuff that they're being asked to vote on. That's a fact. And I know this for a fact because I was part of it. And I saw people, and I actually had one guy tell me, I don't even know why they put me on this panel. I don't know anything about this. I've actually had somebody tell me that. And this
Okay.
guy, I'm not going to say his name, he was an instructor for NFPA. And he said that. I don't know why they put me on this, but he was an instructor for NFPA, and he told me that.
Okay.
That's just fact.
I'm
And
just
I'm
saying.
telling you, I've
But
been
the thing
around long enough and been on all these different standards. I mean, I'm still on this, and I'm about to go off 70E because I got too much going on. But I've been on 70E pretty much since it started. I'm on the EECA committee, which deals with NFPA 496, 497, 499, and I also have been on NFPA 70B. When we were getting all the updates and stuff done for that, they asked us to be on there. And Dad and I have been on those committees. We contributed all that. And then we've gone to all the code making panels. We used to go to all those. I've gone in. When we did the code changes 2 times in a row, or 2 cycles in a row, I actually went to the NFPA convention, and I was the one that did the code changes. And I had all the code making panel members, everything that come to that meeting were coming there and sat in that class. And these were well-known people. And I'd go through everything, explain what they did. Nobody disagreed. And when y'all come out and y'all start attacking the stalk ups like y'all do and say, we don't know what the hell we're talking about, we're morons, idiots, and call us every freaking name in the book. And after all the stuff we done and all these committees and stuff and things we done with NFPA, that is very derogatory. And that's why I got to where I don't put up that. And y'all started that right away when I disagreed with Ryan that there was no outlet. Y'all started attacking our publications and calling us all kinds of names. And that happened, and everybody knows it.
I was wondering when you were going to bring him up because, again, you're the only one that brings that guy up. So
That's when it happened. And I'll tell you how I know
him.
that it's proof, because then I told Bill, and Bill will vouch for this. I said, watch this. I said, I'm just going to say, well, maybe I need to look into this. And I said, watch, Ryan Jackson will comment. As soon as I did that, he come on, oh, that's okay, James. Everybody makes a mistake. And I said, it's funny, Ryan. I said, you hadn't commented once. I said, but I told Bill, if I do this, I said, watch, he'll comment. And he did. And that he's part of y'all too. That's a fact.
And
that happened.
How is he
and
my
that
idol?
happened.
How is he my idol? How is he my idol? How do I do all this
stuff?
stuff?
It's just like you said. I've never met him. And then we showed a picture of you, and there you are. Well, I don't know him that well. Then that's
so he's my idol.
And
I meet
this
somebody
is coming
and that person's
from the
idol?
type of person that says, "Oh, all you freaking Texas electricians are nothing but glorified ditch diggers."
Straight up questions
that
here.
is unbelievable. Somebody would say that.
Oh my God!
No, it just shows the type of person you are.
I don't give a shit. People can think I'm an asshole. People can
That's
hate
what
me.
I'm talking
People
about. I never have made a statement like that towards anybody, just a whole group like that.
Bill
The only time
Bill
I
does.
make comments, y'all, is when y'all started attacking me. I was perfectly fine and just having a code discussion. Then all of a sudden, you, Ted Fritz, Mike Myers, Lloyd, all you freaking guys over there, all of a sudden y'all started, your publications suck, you're a fucking embarrassment to the electrical industry, you're a disgrace. Just started calling me all this stuff because I disagreed with you. And that's what you guys over there do. Y'all attack anybody that disagrees with you. I mean, just look how many freaking posts you put up on NEC for Dummies just attacking me. Constantly. It never stops.
I don't attack.
It never stops.
And again, I don't give a shit.
Yeah,
I don't care what people think of me.
Apparently you care, or you wouldn't be posting all this stuff. I don't post anything about you until you keep trying to attack me.
I care that people get correct information. That's it. All I give a fuck about, man.
And that's why you call them dipshit, moron, and use all kinds of cuss words and all this other stuff, and then you go attack a whole freaking state of electricians. Oh yeah, you really care what people learn on the NEC. Your whole thing is about attacking everybody.
Really?
Yeah, you're constantly attacking people.
I'm attacking where?
All you gotta do is go look. All you gotta do is go to NEC Dummies. Look at all the posts. You got one after another on there, and it's always
going after you. But you say I attack everybody. You say I attack everybody.
Well, sure you do. Anybody that disagrees with you,
show me the proof.
Just like you came on our podcast, you said the only 2 I call or morons as you two. We said, "Huh, you just called this inspector, agreed with us a moron." Well, he is a moron. And that's what I'm talking about. You go in, and if somebody disagrees with you, you call them names.
So 3 people, that's everybody?
Oh, you've done it more than that. I've seen you on them groups, somebody disagrees and you start attacking them. And then you get your boys to come over and attack them too. And then you start tagging everybody. Oh, I need some help. These guys are wearing me out.
I'll correct somebody, and then they'll like, "Oh, you don't know what you're talking." Then once they go after me, then fuck, I'll go after.
They don't go after you. They
but the thing is
they
that
just
correcting
disagree
somebody,
with you. They're not calling you names or anything. They disagree, and then you start calling them names. You've done this over and over. Everybody knows it. It ain't something that is news for anybody. Everybody knows it.
Everybody
all
knows.
they got to
Okay,
do is just follow the comments and read what you say to people.
Love to see everybody out there, and
it's
but,
like you're up. I know
but
what
at least
it is. You're up north in Minnesota. You have your elitist attitude that you're smarter than all of us dumb Southerners down here, and that's why you
never said that.
Well, you act like it when you call all Texas electricians nothing but glorified ditch diggers.
But it's okay that you partner up with Bill, who says all union electricians are uneducated, don't own a code book, that I'm a racist and a bigot, and I personally got people laid off in my class.
I don't know what
he
literally
said.
That's between y'all. I don't get into that.
But you're partners with the guy.
I'm not partners with him. We just do a podcast together. And the reason we do it because we enjoy doing it. It's just something. Okay. It's just a freaking podcast. I don't make any money.
Thank you. It is just a freaking
That's right.
podcast.
I don't make any money off of it. Everything's free. You come in, listen to it. I don't charge nobody any money. I've never asked for any money. But you go.
I never said you did.
Yeah, but that's what I'm telling you. Everything that we do on there, it's my money that I'm spending to put that podcast and everything together. And I spend probably a total of about 2 hours a week getting it ready. I do that for the industry. I give back.
Okay.
You know, and all you do is attack us for it.
I say when I believe you're wrong, and then it just
you don't say anything believe wrong. You come in, oh fuck, king dipshit and blah blah blah. That's how you talk to us.
To you, yeah,
exactly. That's what I'm trying to tell you. And anybody that disagrees with you, you call them names too. That's a fact.
Really? I've had students disagree with me in class. I don't call them dipshits or idiots or
anything. No, because you get fired there. But when you're on the groups and stuff, all of a sudden you're an internet keyboard warrior.
But the thing is, again, I'm talking to you right now. I'm fine calling you a dipshit. I'm not scared. I'm not scared.
Well, the only one that's looked like one so far is you, and you want to disagree. And I'm showing you, taking you back and showing you where it tells you to do exactly what it says. And you don't want to agree with it because you have your point of view and you don't want to be proven wrong. And I'm trying to explain to you, this has been out there for 30 years. Nobody's ever questioned it. And you think you're elitist. You think you're smarter than everybody.
No, because I've seen books. I've seen the ETA, their code calculation books. Sizes.
Oh, I wouldn't go too highly on ETA. I mean, those guys over there, they're the ones, your good union brothers, taking and trying to sell to the non-union and everything and broke off from the NJTC. Yeah, they're a good bunch over there. Those are the same guys when I was going to take a booth over there and Palmer Hickman. Yeah, you hear me, Palmer. I'm calling you out. He's the one that after I paid for it and everything, he saw we were coming. He didn't want them to see how good our material is. So what he do? He denied our booth after we had already paid for it. Yeah, that happened.
Show me that he, in fact,
I don't have to show nothing. You can tell him I said it. He'll probably admit to it.
Jesus
that happened.
Christ.
That did happen. My dad's right here. He'll come over and tell you, yeah, that happened. He knows it happened too.
Super.
It ain't hearsay. That happened.
Okay.
All right.
Well, anyway, it's almost.
Yep. I'm ready to go eat lunch.
Yeah, I got to roll.
I'm hungry.
All right. Later, man.
Later.